On the topic of scientific naturalism and evolution.
During the early 1990s, at a series of academic conferences, Behe first shared his doubts about the ability of natural selection to construct complex molecular machines. One machine particularly attracted his attention.
I remember the first time I looked in a biochemistry textbook and I saw a drawing of something called the bacterial flagellum with all of its parts in all of its glory. It had a propeller and the hook region and the drive shaft and the motor and so on. I looked at that and I said, that's an outboard motor. That's designed, that's no chance assemblage of parts.
Behe's reaction was not surprising, for the molecular motors that drive bacteria through liquid each depend upon a system of intricately arranged mechanical parts. These parts come into focus when portions of a cell are magnified 50,000 times. Biochemists have used electron micrographs like this one to identify the parts and three-dimensional structure of the flagellar motor. In the process, they have revealed a marvel of engineering on a miniaturized scale.
Howard Berg at Harvard has labeled it the most efficient machine in the universe. These machines, some of them are running at 100,000 RPMs and are hardwired into a signal transduction or sensory mechanism so that it's getting feedback from the environment.
And even though they're spinning that fast, they can stop on a dime. It only takes a quarter turn for them to stop and shift directions and start spinning 100,000 RPM in the other direction.
And just like outboard motors on motorboats, it has a large number of parts which are necessary for the motor to work.
The bacterial flagellum, 2 gears, forward and reverse, water-cooled, proton motive force. It has a stator, it has a rotor, it has a U-joint, it has a drive shaft.